In today's lesson, we're going to be learning about the law of cosines and how to use it. So for starters, if we take a look at a triangle, when we're labeling a triangle, the general way that we'll do this is we'll use a capital letter to signify an angle measure and a lowercase letter to signify a side length. And a capital letter will be across from its own letter's side length. Okay, so the first thing that we're going to do is we're going to derive one version of the law of cosines. And this version of the law of cosines is going to be in terms of a side length. So we're looking for a formula for side A, using only the sides and angles from a given triangle. So what we start out with is we have this triangle that's on the coordinate plane, and we've just drawn an arbitrary triangle. It's not necessarily a right triangle. We don't know anything about it except the fact that one side length, in this case side C, the way it's been labeled, lies on the positive x-axis. And then another vertex is up in space, floating somewhere. So what we can do is we can name our vertices. Instead of just A, B, and C like they are here, A happens to be at the origin. We've chosen that carefully. B is somewhere along the x-axis, so its distance away from the origin is C, and then it's up nothing. So that ordered pair is going to be C0 based on our side length here, C. Now, Anglesey, or vertex at Anglesey, is a little bit trickier because it's floating out in space. It's not across C, up B, or A, so we can't name it in terms of ABC yet. What we can do is we can drop this little perpendicular in here and look at this little right triangle that should look really familiar, side X, Y, and then instead of R, we're using side length B, our standard position triangle. And so what that tells us is, well, this point up at angle C is over X and up Y. So that's the ordered pair we'll use there. And so then from this diagram, we can look at angle A and we can come up with a lot of information using X and Y and side length B. So for example, we can say sine of angle A, opposite over the hypotenuse, is Y over B, just like Y over R in our previous units. And we can also say cosine of angle A is going to be the adjacent X over B instead of X over R. Okay, well, both of these we can solve for X or Y. If we wanted to get Y by itself and have an expression just for Y, we can multiply both sides by B. Similarly, if we want X by itself, we can multiply both sides of our cosine equation by B. Okay, so now we'll use those when we're trying to come up with a distance. So we're first going to we're looking for a formula for A, so we're going to look for this distance A, the distance between the point at C and the point at B. So we're going to use our distance formula, and so since we're looking for a side length A, we're going to say A squared, and then we'll use our two ordered pairs to plug in here. Okay, well, instead of X and Y, let's use our expressions here for Y and X. Now what we can do is we can expand each of these out. Okay, so B cosine A minus C quantity squared, and B sine A minus 0 quantity squared, so just B squared sine squared A. All right, so now what we can do is, if you notice, we've got B squared cosine squared A and B squared sine squared A. If we group those two together and factor out the B squared, we can use everyone's favorite trig property, the Pythagorean, to say, okay, cosine squared A plus sine squared A is just 1. So then we're just down to A squared is B squared that had been factored out, and then everything else remains, plus C squared minus 2BC cosine A. So this is one version of the law of cosines. Depending on what side we're looking for and what angle, more specifically, that we have, we can use this formula to find out more information about the triangle. Okay, so that's the law of cosines in terms of a side length. If you're looking for a side length, that's the one that you want, or if you're given an angle. Now, we also want to be able to find out information about the angle. So what we're going to do is we're going to take this law of cosines that we just found, and we're going to solve it for A. That way we'll have a formula in terms of angle A as well as side A. And so the first thing that we'll do is we want to isolate our trig over here. And because it's negative, I'm going to move it to the other side instead. So I'm going to add 2BC cosine A to both sides. I'm also going to subtract A squared from both sides, so I can move that. All right, so we're getting closer. We, remember, want to get A, capital A, angle A by itself. So we need to isolate cosine A. So let's divide both sides by 2 BC. So now we've got cosine A is all of this, but we really want this in terms of just A. So let's use our inverses and just take the inverse cosine of both sides. Looking for the angle whose cosine is b squared plus c squared minus a squared over 2bc. And again, just like the other one, we can have this in terms of any of the three angles. And let's take a look at all of them at once. Is you end up with a lot of matching pieces. Okay, what I mean by that is if you have side A by itself, that's going to correspond all the way over here to angle A. So in your formula, you'll always have something matching on either end. And the same holds true with our angle formulas. So if you have angle A by itself, then the very last side length that's being subtracted, everything else is positive, except for the one that matches the corresponding side length. Okay, so you will have to memorize these formulas, but you'll notice a lot of similarities, and we'll use these so many times and we have to write them out each time. The memorization shouldn't be too difficult. Okay, so now we're going to get into our actual problems. And so for every problem, you're always going to have to draw and label a diagram. And whenever you draw and label a diagram, you have to label all of the side lengths with letters and whatever numbers that you know, and all of the angles with both letters and any given information. And so try not to make all of your triangles appear to be equilateral or isosceles triangles. We want to try to mix them up just a little bit. And so I'm going to start with my angle M. My angle M is 38 degrees, so I'm looking at these three angles. And this one is obtuse, bigger than 90. So that's certainly not going to be 38 degrees. This one in here is pretty big. Maybe, I don't know, a little bit, probably more than 45. So I'm going to go with this one because it looks the closest to 38. So I'm going to label that as 38. It's given. I also need to include the letter. So that's angle M. So then remember that your side lengths and angles, the names, will be opposite each other. So if this is angle M, the side opposite will be side M. Okay, and so then our other two sides will be F and A, and I'm just going to say, well, A is bigger, it's 19, so that's going to be this longer side. And I'll label it with both the letter and the value given. So then the other side must be F. So then the last thing that we need to label, and these are the minimum requirements in terms of what you're labeling on your initial diagram, is we need to label the names of the other two angles. So here's side A, so the angle opposite is going to be angle A. Here's side F, the angle opposite will be angle F. So we've now set up our diagram, and what we're being asked to find is to solve the triangle. When it says solve the triangle, that means find everything that you don't know. So we need to find the length of M, and we need to find angles A and angle F. So let's start off, because we have angle M, let's find the side M using the law of cosines in the original form. If we know the angle, we can find the opposite side very quickly. So each time you have to write your equation with just letters before you show the substitution. This is a requirement. So this will help you memorize your formulas. So we're looking to replace A, B, and C using F, A, and M. We're looking for side M, so we're going to write it out as such with angle M at the end. Okay, once you have your formula written out with letters, now substitute everything you know. Okay, once you have all of that written down, all we're doing is getting our calculator to do the rest of it. So make sure that you are in degree mode for all of these. Okay, so you're in degree mode, just plug all of this in. If you put in the parentheses or the square root, it opens up a parentheses for you, so you don't have to worry about anything else. Once you get that value, double check it, of course, and then store it, because we're going to use it in our future calculations. Okay, so now we know sides A, F, and M. So we have all of the side lengths, but we only have one angle. So we need the other two angles. So what we'll do is we can look for either one. It doesn't matter which one. I happen to choose, I'm looking for angle A first. Maybe it's because I would rather have an A than an F. It really doesn't matter. But just like the first part of the problem, we need to write our formula out with just letters. So this time we're using the law of cosines in its angle form, but instead of A, B, and C, we're using A, F, and M. So what we need to remember is we have angle A, so we're going to be subtracting A squared at the end. then you're going to replace the other two letters with F and M in both places. So go ahead and try it out. Write the formula. Okay, how'd you do? You can check your formula. And the order of M and F don't matter. You could have written F then M or F then M here. What does matter is that if you have angle A out here, you need side A last and being subtracted. All right, so now we can put the values in that we're looking for. Substitute those. You're always required to write your formula with just letters and then with just numbers. And then be careful when you're putting this in your calculator. So make sure that you're pressing second cosine. That's going to open up one set of parentheses, but you need to include parentheses, and I'll draw these in, to close off the numerator. The calculator won't recognize that you're doing an entire big fraction. This fraction bar actually serves as a parentheses, but when we put it into our calculator, it's not showing, so you need to open those and close those. So after you close and you hit divide, then you have to open another one for the denominator. The end parentheses don't really matter. Okay, so go ahead and calculate and make sure that you're doing this step, because if you're getting a different value, then you need to go back and double check all of your parentheses. Okay, so you can check your answer. If you got something different, try again. Be very careful in this step. Okay, and notice I didn't plug in 11.74. I used my stored value. So then you're as precise and accurate as possible. So now we know two of the angles. Well, since we have a triangle, I don't want to go through and use the law of cosines all over again to find angle F. We could write it out, put everything in, and we would get the correct answer. But since we know two of the angles in a triangle, remember that all three angles in a triangle always add up to 180 degrees. So why not just subtract from 180? It'll be a little faster. Okay, so you can calculate angle F. All right, so now we have solved the triangle. We know every side length, M, F, and A. We know every angle, M, F, and A. Okay, so we're going to practice this. So go ahead and use this as an opportunity to test yourself. So set up your diagram, draw everything, practice all of your labels, and then so pause the video so that you can do that, and then check back in. Okay, so you can double check your diagram and all of its labels. Now notice that the angle that we were given was given in degrees and minutes. So in case you've forgotten what minutes are, there are 60 minutes in 1 degree. So if we have this little symbol, this tells us that we have 99 whole degrees and then 56 out of 60 partial degrees. So what I like to do with these is just calculate and then store that value. So I'll store this probably as D in my calculator. Now, you might be given degree measures with minutes and maybe even seconds. I won't make you calculate back into degrees and seconds, but you will have to be able to calculate out of them. Okay, so now that you have your diagram, then go ahead and let's find side length D first. Since we have two of the other sides, it's going to be easiest to find that side length before we find any angles. We're going to need all three sides for the angle in the law of cosines. So go ahead and write out your formula with letters and then with numbers as well. Okay, so now you can check your formula. Once you are satisfied that it's correct, then go ahead and calculate the value for side length D. Okay, you can double check your value for side length D. Don't forget to store this in your calculator. Next, we can find either of the other angles. I chose to find R, so I would recommend finding that first, but you can find either one in either order. We're going to use the alternate form of the law of cosines. So go ahead and write out your formula, show the substitution, and calculate. Pause the video so then you can test yourself. Okay, so double check your formula with letters, your substituted in formula, and your final answer. Okay, once you're satisfied, then go ahead and calculate the last angle, B, and again, I recommend just subtracting your two known angles off of 180. Okay, so now we've had some practice using the law of cosines in both forms to find some side length and angle measures. And that's when we were given the two sides and the included angle. Well, now we're given all three side lengths of a triangle. So using the law of cosines in its initial form won't really work because we don't have an angle measure. So what we'll have to do first on this one, since we have three side lengths, is we'll have to find an angle measure. Okay, and really we're looking for all three angles. So the first step is the same as before. Draw and label your diagram. So go ahead and practice setting that up. Make sure that you're putting 111 as the longest side visually. Okay, so you can double check your diagram. Don't forget you need a letter for every side, a letter for every angle, and then any of the given information. So in this case, the three side lengths. All right, so we're going to find the three angles, and it does not matter which one you want to find first. So if you want to find H first, great. If you want to find A first, great. You could find G first if you wanted to. For both of these, you're going to need to, whatever your first two angles are, you're going to need to set up your law of cosines. So go ahead and write out your formulas. You might as well write for both. And when you calculate, just be very, very careful with your parentheses. So go ahead and find angles H and A, just since they're here, and then you can check your work. So pause the video, find both of them, and then check. And so we need the third angle. Once we have two, we can subtract off of 180, just like before. Okay, so we'll go ahead and practice finding the three angles once you have all three side lengths. So go ahead and draw and label your diagram, and then try the entire problem this time. I will uncover everything, but make sure that you're really testing yourself. When you're checking your work, make sure you're checking to see that you wrote out the formulas with letters and the formulas with numbers. Okay, welcome back. So at this point, you can check all of your work, double check your diagram. Did you label angle K as well as side K and the length for K? Did you label angle T, side T, and the length? Same thing for J. Did you write out your formula with just letters for both of these? Did you write everything out that you were going to plug into your calculator? And last but not least, did you get the same final answers?